Hello everyone, we're standing here today at the World Electrolysis Congress organized by World Hydrogen Leaders. My name is Johann Wiebe from the Hydrogen Standard, and with me here today stands Emmanuel Guilhamon from Rockwell Automation. Welcome, Emmanuel.
Thank you very much. Thank you for having me, Johann. It's a pleasure to be here.
Fantastic for you to be here as well. Thank you too. Rockwell Automation, a big business. You guys do a lot of stuff. Maybe you can give a little bit of an introduction and also what your involvement in the business is and what sort of areas in the company you focus on.
Yeah, thank you. So Rockwell Automation is a large global industrial automation company. So we provide automation solutions, obviously, for a number of industries, ranging from food and bev to energy sector, going through automotive and tire. And on top of the industrial automation capabilities, we also have digital consulting, software, cybersecurity, and all the engineering that goes around this to package everything together. As for myself, I'm the director for the process industries for Europe, Middle East, and Africa, and I'm based out of Paris.
Thank you. That was good. Data. Data tends to be the new gold, some say, and companies over the years collect a lot of data. But the question is a little bit, what can they do with it? And you guys obviously have a solution for that, or at least an answer. Tell us a little bit about sort of the companies that collect the data and what they can do with it.
Yeah, thanks for that question. It's really interesting. We've for years the word has been we need to digitize, and companies have been coming and saying we need to digitize, and what every company wanted to do was to take and monitor all the data, have huge dashboards where they could see everything, and you know, the industry, whether it's Rockwell or other companies, have achieve that for the customers. But now we're seeing kind of the second step that we've been in for a while, which is customers coming back and saying, hey, we have all this data, we have a massive control room, and we can see tons of information, and we're getting all these files in our different systems, but what do we do with this data? And that's really the key to the problem today, is how do you take this data and do something useful for your operations? Ultimately, what you want is you want to reduce your costs, you want to improve your production, and we all know the data will get us there, but the question is how? How do we do that?
So you asked the question, you can also answer it then. How do we do that? And maybe sort of allude to a couple of use cases that you guys are working on.
Yeah, thanks. So I think you're asking the right question. Maybe the best way to look at that is to take a few use cases, because they will illustrate the way we can operate, right? So one of the first use cases is reducing the downtime for any equipment, and for that what we do is we have years of history of data for the facility, whether it's for a desalination plant, purifying, electrolysis, wherever we are in that process, we can look at the facility. We have years of data, and we can look for signs that will announce future failures. So maybe we see that for that specific piece of equipment, a frequent failure will be announced hours, days before, by an increase in pressure or a voltage that's slowly drifting into the wrong place. And so we run machine learning programs that look at this data and are able to announce future downtime. And then obviously the goal is not just to announce it, but also to prevent it. So offers a corrective measure for you to do something on your equipment to avoid the downtime for actually occurring. Another frequent case is looking at optimizing production. How are you going to get more from the system that you are using to produce your hydrogen or whatever process that you're focused on? And there again, what we look at is we look at years of operational data. We look at several parameters and how these parameters will influence your production. What happens if I increase this pressure? What happens if I open this valve sooner? And by looking at all these parameters, we're able to see the impact that they have on production, and then again the system can make recommendations for you to improve your production. And then quickly, the third use case is linked to energy management. If you're looking at hydrogen production, energy is the biggest line of cost in your system, and you have a variety of energy sources that come in, and they have different costs, different carbon footprints. They have different technical qualities to them. The frequency of the energy, the harmonics of the energy that you're getting as an input. So you have all of these systems that come into, and really what you want is you want yourself to have an energy that's going to be as reliable, an energy source that's going to be as reliable as possible, with the lowest carbon footprint as possible, and at the lowest cost possible.
Let me interfere there quickly and ask a question. So the question really is, for data to have a predictive element to it, or some predictive worth to it, you need probably a bit of a history. But hydrogen does not have that much of a history. I mean, obviously it has a history. At the same time, in some industries, much more than others, but not sort of so much on the green hydrogen side. So what would be sort of like the minimum amount of viable data that you need to be able for like predictive elements or sort of like your software to actually make sense? So considering that hydrogen industry is quite a nascent sort of market and emerging and rapidly developing.
No, that's a good question. Yes, for any of these applications, you need to have history of data. That's a given. So I would say that yes, green hydrogen is a fairly new industry, but it's not that new that there isn't enough data. So there is today more than enough data out there to be analyzed to be able to optimize all these processes. There is no, to your question, if you're a new producer, you're setting up a new facility and you're wondering, when will I start to be able to use these techniques? There's no, I cannot say, oh, it's 2 weeks and then you're good. There is no hard number. The more you have, the more data you have, frequently the better. But typically, rule of thumb is after a few months of operations, you already can get some very, very valuable insights on your operations.
Excellent then. Okay, so let's move a little bit to your approach to customers. Do you offer sort of like a standardized solution, one fits all, or is it more customized to what the customer requires?
Yeah, no, thank you. That's a great question. So we are not believers at all in the one size fits all. Every customer is going to have different processes, different plants, different problems. And we are very strong believers in co-innovating with the customer what the solutions will be for that customer. So we have a consulting team that has a lot of experience of working with a number of different customers, specifically in the hydrogen industry, but also in other industries. So they also come with a lot of knowledge from what's been done elsewhere that maybe could be applicable. But ultimately, it will be the customer who will know their business the best, their problems the best, what they think directionally the solutions should be, they will know that the best too. And we can absolutely not work without working with the customers. We would not be able to provide really strong value. We also believe the customers need Rockwell and the experience that we have from working with other clients and other industries, because we also have a lot of know-how that comes with that. Customers do not need to reinvent the wheel. We've probably done what you need somewhere else. So co-innovation is the key here.
Co-innovation, very good. From co-innovation to future aspirations. Finally then, can you tell us a little about what Rockwell Automation plans to do in 2024, maybe and beyond in sort of this space?
Yeah, thank you. So what we're starting to see customers talking about now, finally, is the step 3. Step 1 was gathering the data. Step 2 is what do you do? And we analyze it and we provide recommendations. Step 3 is where the system will self-regulate. Once it has produced recommendations, oh, you should stop this piece of equipment, you should increase this pressure. Since Rockwell builds the control systems, we can also act on the control systems for them to take these corrective actions and for the system to self-regulate. So automation historically has been about individual machines, equipment automating themselves, but what we're going towards with all of this data, artificial intelligence, and all of this digitization of the business, what we're going towards is automating not a piece of equipment, but a whole facility. And instead of having a human controlling a facility and looking at alerts from different pieces of equipment, we're looking at humans controlling a fleet of facilities and alerts that come from different facilities instead of coming from discrete pieces of equipment. So closing the loop, not at the piece of equipment level, but at the facility level. That's the next step, and we're going towards that.
Excellent, Emmanuel from Rockwell Automation. Thank you very much.
Thank you for having me. It's been a pleasure to be here. Thank you.